Hi, my name is Christian Edwards, and I will be doing a presentation over gluten and the benefits of a gluten-free diet. First, here's my outline. I will go through the introduction, defining gluten and how it's classified, prolamins, and then how prolamins are classified and named, and then these things called amylase trypsin inhibitors and toll-like receptors, and then some gluten-related diseases, and then the benefits of an actual gluten-free diet, and then some of the drawbacks that people experience when they have a gluten-free diet, the conclusion, and then my references. So for my introduction, one of the reasons why I chose this is because I have had to experience a gluten-free diet for the past year and a half. I found out I was allergic, and so I thought it'd be super cool to just go and do scientific research over the biochemistry of what's happening to the body whenever someone ingests gluten. And I also saw that there was evident increase in the demand for gluten-free products. So in 2016, it was seen that there was a $15.5 billion more increase in the demand than anywhere else, and that was double of what was spent in 2011. People say that one of the reasons why this is because it's a new social trend. People see that some celebrities are doing it, so they want to do it too. It's more of a social media thing as well, and it's more talked about in the news. And then there has also been an increase in studies showing that people can actually benefit from taking gluten out of their diet. So defining and classifying gluten, it's defined as a group of proteins that are usually found in dough. So a lot of people don't realize is that gluten is not just one single protein. Jacopo Beccari actually discovered that it was in two fractions. There's an alcohol-soluble fraction and then an alcohol-insoluble fraction. And then going off of his findings, Thomas Burr Osborne was able to come up with the four Osborne fractions, which is where certain seeds are put into these four different fractions, which are albumins, globulins, prolamins, and glutamins. And then based off of those four things, they have different functions and different structures. So in the right over here, you can see an example at the very top. It's an albumin. It is a human albumin because albumins can be found in humans, seeds, and animals. The one specifically is an albumin, and it's water soluble, and it is responsible for transporting fatty acids and other insoluble molecules through the bloodstream. So you can see in this protein, there are the red and white structures, which are to represent the fatty acids that bury themselves deep within the protein to protect themselves from water because they are insoluble. And then the bottom protein is a globulin, more specifically an S-globulin. And it's called an S-globulin because it has sedimentation coefficients of about 7. And it's found that globulins are soluble in dilute saline and are also seen as storage proteins. So going off of this, prolamins and glutamins, they have very similar structures, which I'll show you in a second. And prolamins and glutamins are actually the two structures that make up gluten together. So prolamins are the alcohol-soluble fractions, and glutamins are the alcohol-insoluble fractions. So unfortunately, I wasn't able to find any glutamine structures, but the structure on the right is a prolamin structure. And prolamins are just storage proteins, and they're soluble in 60 to 70% alcohol and make up the major components of gluten. It's also found that prolamins have high contents of proline and amide nitrogen, which are derived from glutamine. So there are many different types of prolamins. So there's Zane, which the names on the left column are the Latin names for them, and then the names on the right is translated into English. So there's Zane, which is maize, and then Seculin, which is barley, gliadins, which are wheat, and then there's Hordin, which is barley. So all of these four seed structures contain the gluten protein. So more specifically, those four structures are then put into the proline nomenclature. And based off of their structures, they are divided into sulfur-rich or sulfur-poor, and then there's also the high molecular weight. So for the picture on the right over here, the shaded areas represent repetitive sequences within these proteins. And then the S-rich, so the one in the middle, the SHs that you can see represent cysteine residues. Oh, wait, no, totally kidding. In the HMW, the SHs represent the cysteine residues. And then in the S-rich, the lines represent the disulfide bonds between the cysteine residues. So then in the picture on the left side, you can see the characteristics that each one would contain. So HMW prolamins, they have their polymers, and then they have partial amino acid composition, 30 to 35% of glycine, and so on and so forth. So amylase trypsin inhibitors. So each one of these gluten-containing seeds, so like the maize, the barley, etc., they all contain amylase trypsin inhibitors. And these are just basically a set of compounds that are found within them, and they're highly resistant to intestinal proteases and heat. And so because of this, it causes like toll-like receptors to stimulate in people with gluten intolerances. So toll-like receptors are these receptors that initiate innate immune responses in the presence of unknown pathogens. So in total, humans have 10 of them within their body. And so whenever the amylase trypsin inhibitors, whenever they cause the toll-like receptor number 4 to stimulate in people, it causes the synthesis of pro-inflammatory cytokines and chemokines, resulting in inflamed intestinal tract, which is why people, whenever they take in gluten, it causes this reaction between these two things, which then causes people to like experience bloating and like severe diarrhea and things like that. So gluten-related diseases, we have the first one is the celiac disease, which is kind of the most known, most prevalent, and the most dangerous one. So it's defined as a common inflammatory disease of the small bowel that is precipitated by the consumption of foods that contain gluten. This is like the oldest disease that is known caused by gluten as well. And it was originally only found in places that gluten was located in, but now that there's an increase in consumption of gluten, it has expanded to other locations. So for the United States, in the past 25 years, they have experienced a 5-fold increase in celiac disease cases, and which seems like a lot, but Scotland has seen a 6.4-fold increase in their celiac disease cases. So the pathogenesis of celiac disease is caused by a genetic disposition, which is the only way that someone can get diagnosed, which I will explain here in a second. But if the person contains the genotype HLA-DQ2 or HLA-DQ8, that is kind of like the tell-all that that person will have celiac disease. And because of this, there's a sensitivity to specific antibodies against tissue transglutaminase, which, so when a person ingests gluten, it's partially hydrolyzed by proteases found in the gastrointestinal tract, and then the gluten-derived peptides are then transferred to the mucosa and modified by these tissue transglutaminases. So these are basically just autoantigens, which are antigens that are found within people who have autoimmune diseases, and they're responsible for the deamination of like the gastrointestinal tract. So whenever they do diagnosis, the person has to have a serum antigens treated against the TGT, which they have to have like a 90% sensitivity to this. And it's just like the reaction of this genotype in the transglutaminase. So the picture on the right is an example of the HLA-DQ8 genotype that is found within people who have celiac disease. And they can only be like, someone can only be diagnosed with celiac disease if they have this genotype. Like you can be diagnosed with celiac disease if you don't have it whatsoever. And so some of the symptoms that people experience are like severe diarrhea, skin diseases. So like they experience like severe acne and skin rashes. They also experience osteoporosis and anemia. And yeah, so next we have a wheat allergy. So this is kind of um, it's not as severe as celiac disease, but it's more known than celiac disease, if that makes sense. So it's characterized by T helper type 2 activation, which can result in immunoglobulin E and non-globulin E mediated reactions. So immunoglobulin E takes place due to the presence of antibodies that are wheat specific and are fatal. These reactions end up being fatal. And non-globulin E are characterized by chronic eosinophilic and lymphocytic infiltration of the GI tract. So this is caused by the consumption or inhalation of wheat, basically. So someone could have an allergic reaction if they eat wheat, or what they call baker asthma if they smell wheat particles, which are usually found in people who bake a lot. So it was seen that 3% of children in the United States are diagnosed with a wheat allergy, but by the age of 12, 60% of them have actually grown out of it. So the pathogenesis are cells and basophils release mediators, which just basically means that the Ig antibodies bind with a specific pathogen, which then results in a crosslink of high affinity IgE receptors, which then causes all of the symptoms that people would experience from this wheat allergy. So whether it be a rash or the closing of their throat, which is asphyxiation, I believe, or severe diarrhea for some. And then the way they diagnose this is through a lot of allergy tests and challenges. And then it also depends on like where the person works. So if they just changed a job where they're surrounded by wheat a lot more than what they originally were, they have to do like the skin test where they introduce wheat to the skin and see what happens. And then they also do one that's pretty dangerous where they'll have someone actually eat wheat, and then they'll see what happens to the body afterwards. So some things that these people experience are asthma, abdominal pain, and vomiting. And as opposed to the celiac disease, they don't really experience asthma, but they do experience the abdominal pain and sometimes even vomiting. So the last one is non-celiac disease, which a non-celiac gluten sensitivity, to be more specific. And it's defined as a clinical syndrome characterized by both intestinal and extraintestinal symptoms responsive to the withdrawal of wheat and related cereals from the diet. So this one is kind of more, what's the word I'm looking for? Kind of more of a controversy than the other two, because there's not a lot of studies done on it, because it's more it's starting to become more and more and more, but it's not as known as the other two, which is why there is a prevalence of a range from 0.5% to 13%, but a lot of those were self-reported and they weren't actually diagnosed by doctors. And so they were found that in those studies, in the people who self-reported having this non-celiac gluten sensitivity, they found that it was more prominent in women, teenagers, and those in their 30s or 40s. So for the pathogenesis, the other downside to this is that the mechanism is still also largely unknown. But they did find that people who are diagnosed or diagnose themselves with NCGS tend to have higher levels of TLR2, which is the toll-like receptor 2 rather than 4. And they were able to find this because they they used a real-time polymerase chain reaction to detect the amount of mRNA coding for TLR2. And they found that this was like kind of skeptical, or just kind of like interesting, because TLR4 is the more dominant and more more TLR that shows up than the TLR2. So in order to be diagnosed, like I mentioned earlier, a lot of them are self-reported, and doctors don't really diagnose it until celiac disease or a wheat allergy is ruled out. And something that a lot of these people also experience is abdominal pain, bloating, and surprisingly psychological issues as well. So the benefits to have a gluten-free diet. So in one study that was done, it was shown that 75 patients with fibromyalgia and GI problems were placed on a gluten-free diet for 24 weeks, I believe. And then after they were taken it off, um, patients reported to having improvements in both the gluten, the not the gluten, sorry, the gastrointestinal problems and the fibromyalgia symptoms. Another study was done called a double-blind placebo challenge, where 98 patients were placed on a gluten-free diet for 3 weeks, and then afterwards they were randomized, and half of them received gluten diets, and then the other half received placebo diets. And those who were put on the gluten diets experienced abdominal pain, bloating, and depression. So then there's also those people who have just they're people who avoid gluten. They're not anyone who has a gluten intolerance. They don't have celiac disease, wheat allergy. They don't see a doctor. They just think that there are benefits that come with it and they avoid it. And so those who avoid gluten, they saw that within 1 year of not having gluten in their diet, they experienced a decrease in weight and a smaller waist circumference. It was only about 1 inch, but 1 inch is better than no inches. So there are drawbacks to having a gluten-free diet. So obviously the financial cost. So for every 61 cents of a gluten-containing product, there will be a $1.71 increase of gluten-free products. Which, as someone who has to buy gluten-free products, that is definitely accurate. I never thought that I would be spending $5 to $6 on a loaf of bread, but here we are. And then that just makes gluten-free products about 242% more expensive. Gluten-free products also contain higher levels of trans fat, protein, and salts, which I've also noticed, like looking at the gluten-containing product, like nutrition and the gluten-free nutrition. There's also a lot more sugar in gluten-free products as well. Probably because it tastes so gross, but it's, again, here we are. So also those who are on a gluten-free diet, they won't obtain the right nutrients, which is why they usually end up having to have FDA-approved supplements or vitamins as replacers for those. When I was first placed on the gluten-free diet, I had to take like 50 some supplements a day. So that is definitely a thing. So in conclusion, there are many benefits to removing gluten from one's diet. While there may be some drawbacks to taking drawbacks to take into consideration, like the cost of everything, the positive tend to outweigh the negatives in the situation, or the fact that it seems like most gluten sensitivities are due to the way the protein reacts with the receptors that we have within our bodies. Hopefully within the next few years, and as more extensive studies are done over the matter, more people will start to understand the true benefits of a gluten-free diet. And those are my references.